Thank you. So, hello everyone. Hope you're doing all right. I think this is actually the last slot of the day. So I would like to start with asking for a round of applause for the organization. I think this is a really cool venue. So can we give them a round of applause? Yeah. Okay. And the story I'm going to tell you today is a story about me, actually, about me a couple of years ago as I was being handed a new project. And I was really excited at the time. I was a lot more inexperienced, and I think all of us, whether we're more experienced or inexperienced, I think we're all very excited when we get a new project. So I was very excited. And at the time, my manager, he came to me and he says, okay, there's a new project coming in, Ricardo, you're going to be one of the leads. So just by that, I'm getting very excited. He says, it's for a very important client, it's going to be very good for your resume. And you know, once again, I keep getting more and more excited. He says that the client has been facing some issues and some bottlenecks getting the system, having issues with deployment, and we would come in to help them. And it continues. So the good news is that you'll be managing their entire infrastructure and kickstart their cloud-native journey. So at this point, you know, I start imagining this picture-perfect kingdom with, you know, a big castle, a prosperous village, animals jumping up and down, you know, birds singing, pretty much just like a Disney thing. But it keeps going. The bad news is, you know, that everything else is pretty much on fire. So before I actually get to be a DevOps engineer, I'm going to need to start putting some fires up first. And he wasn't really kidding with this one. I was really in for a doozy. But before I actually continue, who am I? So my name is Ricardo Magalhães. I'm a senior DevOps engineer at techCamp. I've been one for about 8 years. I think it's around 8 years. I'm from Viseu, Portugal. And I started my career as a software engineer, working with React and React Native mainly before actually switching to DevOps. And I also do a little bit of public speaking as well. I've done KCD in Porto, Kubernetes Community Days, IPCon in Surrey, which was pretty great. And I'm really happy to be right here in techCamp today. This is going to be the table of contents for today. In chapter 1, we're going to take a look into, we're going to see an overview of the project and what problems they were facing at the time. Chapter 2, we're going to see how the inexperienced me a while ago decided to tackle these issues and these problems. And then finally on chapter 2 and 3, it's going to be a quick one. We're going to try to wrap everything into Kubernetes. For chapter 1, which I decided to call The Kingdom in Peril, we're going to take a look into the project, and I decided to call this project Ouroboros, and please just make a count of how many times I'm going to mispronounce this word. I think I shot myself in the foot with this one. But what was the project about? So the Ouroboros project was an authentication system, and it dealt with everything from image generation to image validation. So on the image generation side, you would be able to generate a single image or a batch of images, really depending on the properties and the type of product that the client was trying to sell. On the image validation side, you'd be able to take those images and be able to validate them that they were actually generated by our system. Any attempt to create a fake image would be able to be ingested by the system and it would be detected as a fake, even if it was very, very close to a real one. So, in very simple terms, the Ouroboros project was responsible to combat physical and digital fraud for these products. But in the beginning, I was especially excited, or I wanted to know more about the project, about the problems of this project. It was the thing that I was more excited about. So I went to the client and I asked exactly that. And you know, I got a different answer from pretty much everyone that was there in the meeting from the client, and everyone had a different thing to say. Okay, we have problems scaling, kickstarting new services, scaling the team, the business, issues with deployment. You know, a lot of things were going wrong. So everything was pretty much a mess. You know, from all of these that I just described: deployment, scaling teams, services. Nothing was agile, and they really needed help. So if nothing was done, the business would be left behind. And I remember that one of the first meetings, and this one was already with the engineering side of the client. I remember they scheduled a 4-hour slot to pretty much set up a local development setup. And I think, okay, if I need 4 hours to start developing this thing, this monolith. I found it a little bit odd because it was an entire morning's worth of my work, pretty much. So I think it was a little bit weird. But here, I'm going to actually ask for your help because I was going to set up the local environment. So I'm going to ask you, what do you think their portable solution was to people onboarding the project? I'm going to give you a little help. So the project would pretty much start with a bare bones Linux distribution, and then you would just add just about the necessary to make everything work. Does anyone want to try to guess what it was, what they were using to make this portable? Yeah? Okay, Docker? Ansible? Anything else? Sorry?
Virtual machines.
Yeah, okay. So three amazing answers. I'm going to give you one more, Vagrant. Does anyone use Vagrant or used Vagrant before? Yeah, okay. So we got 4 options right now. All 4 of them are great, and all 4 of them would be better than what they give me. So, we have pretty great options, and then they gave me a text file. It's literally a text file. I called it super portable txt. It wasn't called like that. But this is literally what you guys are probably thinking. It was literally a text file with a bunch of commands to run in order to set up these things. So it was pretty, at the time, right now I think it's funny. At the time I was crying, I think. But funny enough, or more funny even, if you follow this thing, this super portable txt, from top to bottom, it wouldn't work. You wouldn't have this thing working. So there are commands missing, others didn't work, others weren't really necessary. So this 4-hour meeting was actually a chance for me and everyone involved to understand exactly what was wrong with their onboarding process. Because as you can see, it's very much problematic. But by the end of it, it wasn't really 4 hours, it was 4.5 hours, so it took my lunch break as well. I was pretty mad about it, but since I was a little, I guess, nauseated by doing all of this, it was jokes on them, I guess. So to set up this thing, you had to go to 4.5 hours of running commands and pretty much hope that nothing got corrupted along the way. So this was pretty much it. This was a pretty terrible onboarding process. But it was time to actually go to the beast itself. We want to see it. And those first meetings with engineering were very much an experience. They were a trip. But it's that kind of trip where you plan to go for a drink, maybe 2 with your friends at your local bar. And for some reason you wake up in Mexico the other day and there's one of your friends has a face tattoo and there's a tiger in the bathroom. I think they should make a movie about this. But there are a couple of things that I think, or 2 bullet points that I think, I guess when we're discussing monoliths, there are others, but these 2 scream louder in my head, so single code base and tightly coupled. But let's actually meet the beast itself. So let me say that I looked into their monolith after the problems they described to me. I looked at it just like this, and I imagined this. Let's actually meet the services. So let's call them Ares, Poseidon, Apollo, Zeus, and Athena. These were the services. Usually, you see a monolith that, all the pieces work together in tandem very well. So you have a catalog service, you have a shopping cart service, an analytic service, metric service. It makes sense. They work together to form this centralized unit. This one was a little bit different. So each one of these was also a client. So it's pretty much a tenant. They were managing different tenants in this monolith. So as you can imagine, the monolithic structure, if you think about its problems, I think you can multiply those by 1,000 when you think they were managing different tenants here. So I wanted to check for myself. So on my machine, I took one of them down. So I took Poseidon down and see what happened. As you can imagine, everything else wasn't working. So if the Poseidon client was down, no one else could operate, which I think it's pretty terrible. So if, for example, the Apollo guys came to you asking why they're down, you'd be like, they were like, okay, did we do something wrong? You'd be like, no, just the neighbor just kind of screwed up. So I guess this is pretty terrible to the clients. When we're talking about monoliths, I think there are a lot of advantages of why we should use Monolith, especially early on when your project hasn't grown too much, your team hasn't scaled too much. That centralized unit early on has very little low cognitive overhead. Testing is a breeze. It's very easy to ship because everything ships together. You can develop very fast early on in a performance. You don't have to jump around a lot between different components and services. So it works pretty well. But as you can imagine, as time passes, the complexity starts to grow as well. And in the beginning, you were developing very fast, but right now the number of modules kept growing, and now that development speed starts to decrease, and you start having a bunch of other issues. So you can't scale individual parts of this monolith. Everything is going to ship together. If something needs to be deployed, everything needs to go together. You develop this thing in a certain technology. If you want to expand, you're going to have a lot of issues. It's not impossible, but there's issues here with the new technology adoption. And then, of course, debugging, it's going to become hard over time as your service and your model continues to grow. OK, so I'm going to give you more context, a little more context of the project. They were having some issues. Their former team actually completely moved out once we entered the project, so there was a lot of issues. Understanding what was done, documentation was non-existent, or the one that existed was not good. And at the time, you were ongoing a migration. So we were moving most of the components from the C language to Python. At the time, it makes sense because the Ouroboros team, the new people that came in, had knowledge about Python. There was a machine learning component also in the project where they were taking advantage of NVIDIA GPUs. They were using PyTorch and stuff. So this change at the time, it made sense. But very early on, after I actually moved in the project, they were like, OK, currently we have 5 services. We need to scale up 7 more, like from night to day. And I think, OK, this is not going to be doable because we're not using Elm charts. We don't even have these Dockerized. So, this is a problem. It's not doable. We cannot just spin up a new Elm chart, update a couple of values, and then in a couple of hours we have all of these services pretty much going. So in this short arc of a story, there are 2 glaring issues. Kickstarting new services was pretty much impossible from night to day, and separation of concerns was inexistent, especially when they tell me that there's a new team that's going to come in and start managing 2 new services. And especially because I need to take this monolith and send everything to their side. And we're talking about code that has client-specific configuration and secrets exposed, which means other teams would have access to this thing. And as you can imagine, this is a huge security breach. So I'm going to make a little disclaimer here because it might seem like I'm preaching that monoliths are bad. I'm not saying that. I'm saying that in this case, it made complete sense to move into a microservices architecture because we were growing into it. Okay, that's when you should move into microservices. You grow into them. Actually, funny enough, in one of my most recent projects, we actually went the other way around. So we went from microservices to the monolith because it makes sense. The team wasn't big. We didn't have a lot of services. It just didn't make sense to continue using microservices. So we went back to the monolith. But since we're talking about why it made sense to move into the microservices, we need to take a quick look into it. So deployment-wise, there was real deployment fear in this project. And it's not the deployment fear of deploying on Friday at 5 p.m. It's deployment fear of deploying on a Wednesday 10 a.m. OK, these guys did not want to deploy at all. So it was real fear there. Scaling issues. They can't scale the team. They can't scale services. They can't scale anything. So chaos was pretty much at every corner. And if nothing was done, the business would be left behind. At the time, the client, and I think today as well, they were the leading, products in the market for this. But with all of the problems that they had, they knew that eventually someone else would come in and just take their place because they weren't evolving. So the plan here is to understand the thing, understand the monolith, look into the beast that is the thing that we're using to imagine this monolith. Understand the pain points. Okay, this thing has fire, so it's going to burn us. It has claws, it has fangs. There's those spiky things on the back. So we need to understand this. Also, we need to understand the weak spots. Maybe if we can cut off the heads and deal with them individually, maybe we can have them work in our favor instead of having this whole beast, just pretty much terrorizing our kingdom. And by the end, what we actually want is to be able to break it down and eventually get to a point where we have a system that is more portable, modular, and of course scalable as well. Okay, let's talk about the pain points. I know since the beginning that managing dependencies is going to be tough. Okay, there are dependencies that are deprecated. I know I'm going to have to untangle all of them because the base part of the technology itself, it's pretty much the same, but for each client there are things that are very much specific, and we're talking about dynamic libraries that actually constitute the main development points for each of these clients. In terms of hardware dependencies, I mentioned a machine learning component in the project that they were using NVIDIA GPUs. Local file system dependencies. Okay, this is another thing about the project. They had a testing workflow where they have this they have this folder that is actually available in the network where the images would be generated, and then machines, which were actual physical machines, would have access to that folder. They would download the images, download and print the images, and then there was another machine that performed tests on them. And then, of course, I already mentioned the hard-coded secrets and client-specific configuration. Okay, so the road ahead is to get to a point where we have our microservices architecture, we have Jenkins orchestrating everything for us, and we're taking advantage of tools like Helm chart to spin up new services. Maybe we're even setting up and versioning our infrastructure with a tool like Terraform, but this is pretty much a long way until we reach there. For now, we actually need to fight the beast with other weapons, and I decided to choose these two to start fighting the beast. So Docker and Jenkins. With Docker, I wanted mainly two things. So the first one is to actually deploy this application, okay? Have an easy way to deploy this application. The second is, once I'm able to containerize this and spin up containers like this, maybe I can start going in, start taking things out, updating dependencies, running tests, see if it works, and and leverage containerization for my benefit in order to start untangling dependencies and fixing issues. With Jenkins, I want automation, of course. I want to take away any kind of manual intervention in terms of deploys and be able to automate pretty much any kind of pre-deploy instruction that there is in this project. But right now we actually have to talk about the elephant in the room because it's 2025, so AI. Let's talk about AI. AI stands for artificial intelligence, right? And no, that's pretty much it. Okay, let's go back to the dragons. So, chapter number 2, we're actually we're going to see how the inexperienced Ricardo decided to tackle the problems that this system had at the time. And we were doing a migration at the time, but I couldn't wait for it to be done in order to start fixing problems. I needed quick wins, okay? I need to show service, I needed to make things work. And the first thing that came to my mind is, they don't want to deploy this at all. They're completely afraid of messing something up and then having multiple clients down when they didn't make any kind of mistake. So let's try to fix this. So I came up with a solution. I came up with a solution that you're not gonna like, but I ended up fixing this issue. So, and in this point, I actually like to believe that we are masters of the craft first, and then we're actually problem solvers first, and then masters of the craft, okay? So here's the solution. Okay. So we had the monolith as is, that big centralized unit. I made a Docker file of it. Okay, I made a big big Docker file, and the containers were huge. We're talking about gigabytes huge. This is not great, it's not a good starting point, but it was actually the first step to fixing this deployment fear or taking away this deployment fear from the project. Because we were able to do something like this. We were able to set up a reverse proxy using Nginx and then spin up individual container instances for each of the services, and then based on path, we would be able to just route the requests for the specific service. This way, if one of the clients was down, if Athena was down, everyone else would be able to continue to operate. So this was pretty good. Also, if one of them is down, there was a simple and quick way to get it back up again. It was very simple. Just need to spin up a new instance. But after a while, we eventually were able to complete the migration. So this was a pretty great victory. And another thing that we were able to do was that the single process that was terrifying, that was, I guess, causing so much trouble to this client, we were able to separate these services in a way that they could be run individually. So if one of them is down, nothing else was down as well at the same time. So the single process was completely over, and now we could run and, I guess, sleep at night better, knowing that we can run each of these clients individually, this outside Docker, of course. But now there were other issues that we still needed to fix, starting with the dependencies. I knew there were a lot of things that I had to do in terms of dependencies. You know, I have to untangle dependencies. I need to understand what is the base part of the project that constituted the base for all of the projects, and I needed to understand what was specific to each of them. I needed to understand and take away things, and still at the end of the day, make sure that each of the clients can actually operate on their own with dependencies untangled, with all of that bloat in terms of dependencies. So this was the first step, is to understand this. What is the base and what is service specific? Since I'm now able to spin up containers like this, let me leverage that, let me go inside, take dependencies out, let me bump dependencies, see if it works, run the tests, you know, make whatever is necessary to make sure that everything works. But as you can imagine, there was a lot of dependencies to untangle, so this is probably not the best way to do it. So at the time, I was investigating a couple of ways that I could do this in a faster way. So I found, one of the tools that I found was DebFoster. You probably know about it, but this tool, this is a CLI tool that actually runs interactively and starts showing you, okay, package X, this is the transitive dependencies that it brings with it. Do you want to uninstall it? If yes, it uninstalls that, and there's also an option to uninstall all the transitive dependencies. And this tool at the time actually helped a lot because I was able to untangle dependencies a lot faster. And when it comes to decreasing container size, this was actually a pretty good help. Okay, we've covered a lot, so let's go quickly through a timeline. We started with a monolith where a single process was pretty much running everything, which was really problematic. We came to a quick fix, which was not great, was not ideal, but it worked. It was a quick win. We completed a tech stack migration into Python, which was also good. We got to a point where services were running independently, but there was still a lot of bloat from the monolith. There were still a lot of dependencies that were in each of these services that we needed to understand what was specific and what was the common part. And then finally, we got to a point where the services were optimized. We were able to untangle dependencies. We were able to get rid of all of that bloat. So it was time to actually do the first version of an optimized Docker file for it. So we understood what was the common part and what was the service-specific part. Let's build this container. Let's build a Docker file. So there are mainly a couple of ways we could have done this at the time. The first one was to have every single instruction in the same Docker file and maybe even leverage multi-stage builds. This was option number one, or manage these two separately. We have one Docker file for the common part, which was the base part that didn't change a lot over the course of the project. I think since I actually got in, I think it changed 2, maybe 3 times, so it didn't change a lot. And then manages the specific part in a completely different Docker file, which was the way that we decided to tackle this at the time. So we take everything that is the specific part of the project, you know, the base part of the technology, and we stick it into an image that we're going to call a robuste core. And then for the part that is specific for each service, everything that is specific to Athena, let's take that, put everything on the Athena image, and then of course the base image for Athena is going to be Ouroboros core because it has all of the base for the common parts of this technology. So this is what we decided to do at the time. It reduced complexity in terms of maintaining these images. It made sense to separate these two. It made a lot of sense at the time. Now we need to solve other issues. So starting with the hardware dependencies, the dependencies, or I guess the need to leverage NVIDIA GPUs in this project. Docker out of the shelf cannot do this automatically. I think, or at least at the time, it wasn't able to do this. There were things we needed to install in order to make this work. So the first thing we need to do is to actually install the NVIDIA drivers. At the time, the machines that we were working with and deploying these services already had the drivers, but the first thing you need to do is to install the NVIDIA drivers. Second thing is to install the NVIDIA Container Toolkit, which is going to provide the NVIDIA runtime that you need to run in Docker in order to leverage NVIDIA GPUs. And then finally, you have to tell Docker that you want to use it. With the -- runtime flag, you can specify the NVIDIA runtime. And then with the GPUs, the -- GPUs, you can specify what GPUs you actually want to leverage. Now, the local file system dependencies. This is also why this is a story about inexperience, because there were some decisions that we knew that they were wrong, but we kind of work around them. This is a good example. So there was a local file system dependency where there was that folder, let's call it generated, where the images would be generated on that folder. It was available in the network. Machines would be able to have access to this folder, take the images out, print these images, perform tests on them. Okay, we need to do this in Docker. And you do not do this in production. You do not use bind mounts in production. You do not use them. We kind of work around it. And at the time, we used bind mounts in production, so we were simply mapping this folder from the container out in order to generate these images. So obviously, this is a very bad practice. But that's the way that we chose to tackle it at the time. Obviously, it's not a good practice. But we're going to come with a proper solution ahead. So let's stick with the plan. Okay. Finally, we have all of the hard-coded secrets and configuration that were in the code. And I'm not going to go over why this is a bad practice. Every single one of you know why this is a bad practice. We need to take them out of the code, okay? So since we're leveraging Jenkins, since we're using Jenkins, why not use the ability of Jenkins to actually manage these secrets in order to move the secrets there? So this is what we end up using at the time. And since we were building Docker images there, why not inject them at build time? Finally, let's try to wrap everything quickly into Kubernetes on chapter 3, orchestrating victory. So in here, we decided to cut the beast's head, and right now we had different heads. Okay, we had different dragons that were working for us, but now we need to go to the cloud. Let's actually make the dragons fly. Okay. At the time, we ended up going into AWS. This was the cloud provider that client was using, so we went with it. And in here, and this is why I chose to set up the presentation like this to showcase Docker's importance, because we already dealt with all the problems before. So let's go one by one on how we decided to tackle this in the cloud. So the first one was to actually leverage NVIDIA GPUs. This is what you need to do. First, you need to pick compute capacity that actually provides NVIDIA GPUs to you. Then you need to install the NVIDIA driver plugin, and then finally, you need to tell the Kubernetes pods to actually request those resources. So let's go. First, pick compute capacity. On AWS, there are a couple of EC2, I guess, AMIs that you can use. You need to pick one that actually has NVIDIA GPUs attached, so we go with accelerated computing. Then we need to install the NVIDIA driver plugins on the nodes that actually need to execute the machine learning component workloads. So we can label the nodes with something like EKS-node equals GPU, and then use Helm chart to install it on those nodes. And then the only thing we need to do is to actually to request those resources from the Kubernetes pod. So with this field right here. So resources limits nvidia.com/GPU, and then the number of GPUs you want to leverage. Local file system dependencies. This was the decision. This was the option, the one that we knew we weren't doing well in Docker. So let's see how we fix it. We used a Docker bind mount. That was not a good practice. But since we're in the cloud, why not leverage the fact that we're in the cloud and use a service like S3 and object storage to actually store the images, and then the test machines will be able to download these images and perform tests on them. So exclude this folder completely. Finally, secrets. We went from exposing the code to managing in Jenkins. Now we're in Kubernetes. Why not use AWS Secrets Manager to actually store these secrets, and then use something like the CSI driver plugin, or in this case, the option that we took at the time, which is the external operator that's going to fetch those secrets and inject them in the cluster as native Kubernetes secrets to actually manage these secrets for us. Finally, let's go over what was achieved since the beginning. So we had a single process in this monolith that was terrifying this kingdom, managing everything together, all of these services together. If one of them is down, everyone else was down, which was extremely problematic. We went to a point where we Dockerized the entire thing to fix the deployment fear and the deployment problems that they were having. We moved the secrets to Jenkins. We got to a point where we built an optimized version of the Docker file for each of the services. And then finally, we got to a point where everything is in Kubernetes, both the services and the secrets being managed there. So this was the journey. We eventually got to Kubernetes, but I structured this talk to showcase how Docker was important, paving the way, understanding the problems that we were facing. Once it was time to actually put things in cloud and transitioning into Kubernetes, it was a matter of adapting a couple of things in order to get there. So I hope you enjoyed it. My name is Ricardo Magalhães. These are my handles, and thank you very much for coming.
Thank you so much, Ricardo, for giving us this speech. Yeah, it was the slot for the hard people who stay here until the very afternoon. So, what about questions? Last round. Is there somebody who has a question we can answer? Oh, that's far away. Wait, I'm coming. And but the time is not enough to tell you another Chuck Norris joke, so I'm going to do it without.
Thank you. Maybe I missed it, but how long did the transformation take?
Yeah, I literally get this question every time I do this talk. And I don't remember at the time, but I know it was, at the very least, it was 1.5 years. Yeah.
Seems fast to me.
In perspective, yes, but yeah.
You suffered. You wanted to say you suffered for 1.5 years.
Yes, several
but it
times.
was okay. More questions? Come on.
Why did you not, given that all your clients basically share the same code base and are a config difference, why did you not go for one core and then use something like GitOps or so to configure the tenants?
Yeah, at the time, to be honest with you, I wasn't even aware of the concept of GitOps, but that would be the, I guess, one of the go-to options to take. You know, maybe with something like customize on top of it. But I guess I still see that as the end goal of it. I still think we had to go through the process of, you know, going through Docker and somehow split everything up and tangle dependencies. I still think that as the end goal, not necessarily the stuffing in the middle. Yeah.
Okay. I'm staying in the middle of the room, that's easier. But nobody's talking to me. Okay. So then, thank you very much again. Then you're released from the stage. Very, very right. Thank you.
Thank you.